Today I am going to solve, this is physics 2025 CBSE board, class 12. The first question is, the figure shows the voltage V versus the current I, graph for a wire at two temperature T1 and T2. One can conclude that. So here you see that I have to move from resistivity, that is rho T, that is equal to rho naught bracket 1 plus alpha constant T minus T naught. Now here rho T, this is simple algebra, so this will be equal to 1 plus alpha T minus T naught. So here rho T by rho minus 1, so this will be alpha T minus T naught, and this comes to be, this is rho T minus rho naught by rho naught, that is equal to alpha. We can say that this is change in temperature delta T, here this is change in resistivity, so this will be alpha delta T, and this is your rho naught so this will be rho naught. So here you see that your this rho is proportional to delta T. So when your resistivity increases, that is temperature increases, your resistivity increase. So now again increase, this is increase in resistivity, less is the flow of the current, less is the flow of the current, less is the flow of the current. So less is the flow of the current. So here you see that in the figure we take this voltage, so here at T2 your current is this one, at that same voltage for T1 the current is here more than that in T2. So from this we conclude that because there is increase in resistivity, so because there is the current flow decreases, because with the increase in resistivity we can conclude that current flow decreases. That means increase in resistivity is because of the increase in the temperature. So from this we conclude that your T2 is, from this we conclude that T2 is greater than T1, or you can say that T1 is less than T2. So this is your answer. Now I am going to the second question. Here I am going to the second question. This is the second question. Here RS and RP are the equivalent resistance of AND resistors, each of value R in series and parallel combination, then the value of RS minus RP. So this is nothing else. Here we know that RS, so there are N resistors, so this will be NR, and your RP, that will be equal to R by N. So now here again you see that RS minus RP, that will be NR minus R by N. So if you take R common, so it will be N square minus 1 by N. So your C is your answer. Now I am going to the third question. The value of field at O in the given figure. Now here this is a question of on Biot-Savart law. We take this linear values. So here your DL and I are in the same direction, so your angle is 0. So here the magnetic field here and the magnetic field here is 0. So the magnetic field is only in this curved portion. Now this is your position vector, this is your origin. So here magnetic field due to the semicircle. Now this is the magnetic field, magnetic field due to the due to the due to the semicircle, magnetic field due to the semicircle. Here this will be, here you see that your DL is perpendicular to R, DL is perpendicular to R. Here you will find that your DL is perpendicular to R, so sine 90 degree. So your dB that will be equal to by 4 pi, that is I dl sine 90 degree by r square, sine 90 degree by r square. So here you see that sine 90 is 1. So for the whole semicircle we integrate it, that is dB, that is equal to by 4 pi, that is I by r square integration dl. So this will be equal to 4, this will be equal to I by 4 pi r squares. For semicircle it will be pi r, so r pi cancels out, so your answer will be I by 4r. So option C is your correct answer. Now I am going to question number 4. Question number 4. A piece of diamagnetic material is free to move when placed in a uniform magnetic field. So here we know that diamagnetic material, for your diamagnetic material, diamagnetic materials moves from stronger, it moves from stronger field to weaker field, stronger field to weaker field when placed in an external magnetic field, So and next external magnetic field, your external magnetic field, this external magnetic field will repel, it will repel a diamagnetic substance. So since it repels, so it moves opposite to the field. Now my next question is, a galvanometer can be converted into an emitter of desired range by connecting a small resistance. It will be a small resistance in parallel, parallel. Now my next question is, a proton, let me scroll it. So here a proton and an alpha particles enters with the same velocity in a uniform magnetic field such that V is perpendicular to the B. Let us consider that it is magnetic field is into the plane of the paper. Magnetic field is into the plane of the paper, and your velocity of the perpendicular to the magnetic field. So we have to find the ratio. So here you see, first let us take for proton the mp, this is for proton, v square by rp, radius of the proton, that is equal to qvb, because velocity, originally the formula is f is equal to q v cross b, v cross b. Since v and b are perpendicular, so sine 90, so it will be 1. So this is the force. So here your rp will be mass, so a proton, and so here you see that m, one proton, m v square by rp, and this is equal to q vb. This is rp. So this is equation 1. And now for this alpha particle, that is alpha, it is mass will be 4 mv square by r alpha, and it has 2 protons, so 2 charges, so this will be 2 vb, 2 q vb, that is equal to 2. So now this is rp. So now we have to find the ratio of their path, that is rp. Now your rp, that will be equal to mv square by qvb. So let this be equation 1. We rub this. So, and r alpha, its mass is 4 m v square by charge is 2 protons, so qvb, this is 2. So now here so this will be equal to 2 mv square by qvb. So this is equation 2. Now here rp by r alpha, radius, that will be this divided by this. So here you see all this cancels out, so your ratio will be 1 by 2. This is your answer. Now I am going to the another question, that is here vertical held bar magnet is dropped along the axis of a copper ring having a cut as down. Because now here, because there is the current, there is no current flow, because it is a cut here, because there is no current flow, there is no induced current flowing through it. So there is no induced EMF, so there is no opposing force, so the acceleration of the fall will be, your acceleration will be g, your acceleration will be, the C option is correct. Now here an AC source is connected to a resistor and an inductor in series. The voltage across the resistor and inductor are 8 volt and 6 volt. So respectively the voltage of the source, we have to find the voltage of the source. Voltage of the source, that is V square, is equal to V R square plus that is V capacitance minus V X V capacitance by inductance. So VL the whole square, here is no capacitance, so this will be VR resistors, it is 8 square and no capacitance, so 0. So VL, this is 6 square, so this will be 6 square, so this will be 100, and so V will be equal to 10 volt. So this is your answer. Now my next question is, two coherent waves are produced. I naught produces interference pattern as on the screen, the average intensity. So I will be equal to 4 I naught, 4 I naught, here I will be equal to 4 I naught cos square 5 by 2. Now we are going to take the average. So average, this will be 4 I naught, and average this cos square 5 by 2. Average of cos square 5 by 2 is 1 by 2. So I naught into 1 by 2. So this will be 2 I naught. So answer is C. Now I am going to the work function. Here the work function, that is for, you must remember this, for violet light, your wavelength is 390 nanometer, and your work function, that is energy of a photon, this will be 3.19 electron volt. Whereas for red light, you will find that for red light its wavelength is 550 nanometer, and its energy, that is energy of the photon, it is 1.64 electron volt. So this is less than 2.21. Here it is given in the question, it is less than 2.21. So which cannot produce photo electrons. So this will be the blue light. So your answer will be blue light. Your answer will be blue light. Now my next question is, let me scroll it. Now next question is my next question is the momentum of a photon frequency is this. So yeah, momentum, your frequency is given here. Now you have to find the momentum of a photon. Your frequency, it is given here. So the formula is P is equal to H frequency by C. H is the Planck's constant, so this will be 6.63 into 10 to the power of minus 34 into frequency, it is given to you 6 into 10 to the power of 14 divided by 3 into 10 to the power of 8 meter per second. That's the speed of the light. When you solve it, you are going to get 1.326 into 10 to the power of minus 22. Solve it. Sorry, it will be minus 27 kg meter per second. This will be your answer. Now here for the third question, inside a nucleus, the nuclear forces between proton and neutron. So your answer, your last will be your answer, that is F force between proton is equal to force between proton-neutron is equal to force between neutron. Now my next question is here. Here you see that this, it is not connected, it is only wire is connected here and here. We have to find the equivalent resistance between A and B. So here you see that 5 by 15, it is 1 by 3, 10 by 30, it is 1 by 3. There is therefore no current is flowing through it. So these two are in series, these two are in series, and these two are in series, and again they are in parallel. So your equivalent resistance R dash will be equal to 1 by 15 plus 1 by 45 plus 1 by 45. So your LCM will be 45. So this will be 3 plus 1 plus 1. So your R dash will be 45 by 3, 4, 5 by 5. so this will be 9 ohms, and with plus 1 ohm, so this will be equivalent resistance will be 1 plus 9, that is equal to 10 ohms. This will be your answer. Now I am going to another question, that is a point source of light in air is kept at a distance of 12 centimeter. So air, let us take the refractive air, that is equal to 1 in front of a convex spherical surface of glass, refractive index, so glass, that is N2, here refractive index is 1.5, and radius of curvature it is given to you, that is 30 centimeter. Find the nature and the position of the image form. So here N2 by V is equal to N1 by, sorry, this is minus U, this will be equal to N2 minus N1 by R. So your N2 by V, we have to find it out. N1, that is again equal to, this is minus N1, that is air 1, and minus 1 by 12 because it is on the left side, and this is equal to 1.5 minus 1. Radius of curvature it is 30. Radius of curvature it is 30. So here you find that N2 by V plus 1 by 12, 1 by 12, this is equal to 0.5 by 30. So now N2 by V, that will be equal to 5 by 300 plus 1 by 12. So 5 N2 it is given to, N2 we have, I have N2 N2 it is given to you, it is glass 1.5, so this is 1.5 divided by V is equal to, here your LCM will be 300, so this will be 5 minus 25. Now if you solve this, you are going to get V is equal to minus 225 by 100, 10, 225 by 10, 225 by 10, and this will become minus 22.5 centimeter, 22.5 centimeter. Now going to the next question. Your next question is, find the intensity at a point on the screen in Young's double slit experiment at which the interfering wave intensity to I naught each have a path difference. Here this is given to you. So we know the formula I is equal to 4 I naught cos square phi by, this is phi by 2. We know this formula. So here phi is the path difference, phase difference. Phi, your phi is the phase difference. This is your phase difference. This is your phase difference, and this phi, this is equal to 2 pi by lambda into path difference, So at first your path difference was lambda by 2, so 2 pi by lambda into lambda by 3, so this will be equal to 2 pi by 3. Now your intensity I will be equal to 4 I naught cos square, 2 cancels out, this will be pi by 3, cos 30 degree is equal to 1 by 2 square, this will be 1 by 4, so this will be 4 I naught into 1 by 4, so this will be I naught. And in the second case your phi, in the second case phi that is equal to 2 pi by lambda. Path difference is lambda by 2, so this will be equal to pi. Your intensity will be 4 I naught cos square pi by 2, so this will be 0, so this is equal to 0. So this is your answer. Now my next question is, a laser beam produce average this much power, so energy of the photon of the beam, and second the number of electrons. So energy of the photon, this will be here your E will be is equal to h frequency. So frequency of the beam, it is given to you 6.63 into 10 to the power of minus 34 into frequency, that is 3 into 10 to the power of 14. So this comes out to be, this will be equal to 19.89 into 10 to the power of minus 20 joules. So here number of photons will be, this will be for how much, this much energy. For number of photons will be 9 into 10 to the power of minus 3 by 19.89 into 10 to the power of minus 20. So this comes out to be 0.45 into 10 to the power of 17. So this will be 4.5 into 10 to the power of 16 photons. This is the number of photons. Now I am going to the next question. Here your next question, here you will see that regular loop carries a current 1 ampere. Here it is shown here 1 ampere current is flowing through this loop. Here it is flowing through this loop, and a straight wire which is carrying 2 ampere current. So we have to find the first torque. Torque will be 0 and the magnitude and direction of the net force. Now first of all, at this here your magnetic field, at this side your magnetic field will be B1, that will be equal to I by 2 pi r, that is equal to I by 2 pi, your distance is 1 by 100. So this will be equal to 1 centimeter. It is 1 centimeter apart. So 2 ampere current is flowing through it. So this will be here 2 ampere current is flowing through it, into 2 divided by 2 pi, and this will be into 100. So this comes out to be 100 by pi. So this comes out to be by pi. Now this much Tesla. Now magnetic field, because of this wire, magnetic field produced at this side, the magnetic field produced at this side, this will be B2, that is equal to I by 2 pi r. Here distance is 1 centimeter plus 1 centimeter, 2 centimeters. So this will be equal to into 2 centimeter, that is 2 by this current is 1 ampere, 2 ampere current, and here 2 pi, 2 by 100. So here this will be equal to your nu naught into 100 into 2 by 2 pi into 2. This cancels out, and this will be equal to into 100 by 2 pi. This will be the magnetic field here. Now force here, that is this is the current carrying a wire which is placed in a magnetic field, this. So here your force will be equal to this will be F1, this will be equal to I LB sine 90, because the magnetic field and this will be perpendicular to each other. So this will be ILB sine 90. Sine 90 is 1, so it will be ILB. So here now if you place value of the current is 1, length is 1 centimeter, that is 5 centimeter, 5 by 100, and your magnetic field is 100 by pi. So your 100 cancels out, and the force will be F1 force. Here your F1 force will be 5 into 100 cancels out, so this will be by 100, this will be 100. Now similarly your force here F2, when this wire is placed in the magnetic field, this here your force will be again F2, this is F2, that is equal to ILB. Again 90-degree magnetic field will be perpendicular to this length, so here IL cross B perpendicular length. So here again your I is how much? I is 1 ampere current is flowing through it. L is your 5 by 100, and B is your how much? This is your, that is B is your into 100 by 2 pi. So this is your force here. So this is your F2 force. 100 cancels out, so this will be by 2 pi. So this is your F2 force, this is your F2 force, and this is your F1 force. This is your F1 force. So your this is your F1 force. So your net force here will be net force will be F2 net force F1 minus F2. Net force will be F1 minus F2, that is 5 by F1 F1 100 cancels out, only pi, this is only pi. So pi minus by 2 pi, so this comes out to be by 2 pi. Now if you place the value of this will be 5 into 4 pi into 10 to the power of minus 7 by 2 pi. So your result will be 1.6 into, not 1.6, this will be 1 into 10 to the power minus 6 Newton. This is your net force, and your torque will be 0. Your torque will be 0. Now let me move to the next question. Next question. Going to move to the next question. That is here. This is an ideal transformer. Here this is an ideal transformer. So here you see it is a step up transformer, because 50 volt to into 250 volt, and it draws 200 amperes of current, and your V1, that is input voltage, it is given to you VI, that is given to you 20 sine 100 pi into T. This is given to you, this much voltage is given to you. So now your input current in RMS, so here your Vrms, that is equal to 20 by root 2, and this comes out to be 10 root 2. So power, this is equal to Vrms into Irms cos phi. We are going to take cos phi as 1, so here your power is 200, and Vrms is 10 root 2 into IRMS. So here your IRMS divided by 10, 0, it will move to, so your IRMS will be 10 root 2 10 root 2 ampere. Your IRMS will be this much. Now we have to find expression for instantaneous voltage. You have to find in. So here you see that we know that Ns by number of turns by Np, that is equal to Vs by Vp, secondary by primary. Your secondary, the output is 250 because it is a step up transformer, so this comes to be 5. So now your V output by V initial, that means input, that is equal to 5. So here your V naught will be equal to 5 Vi. It is given to you here. See, this is your Vi, this is your Vi. So into 20 sine 100 pi 100 pi into t. So this will be equal to 100 sine 100 pi into t. Now this is your expression for V output O. Similarly we have to find out for current. So this will be Ip by secondary, that will be equal to Ns by Np. Your Ns by Np, here your Ns by Np is your 5, this is your 5. So your Ip 5 input, that will be 5 Is. Now here you have to find out Is. For this you have to find out, we know that your IRMS is equal to I by I naught by and this is for a primary, that means input, IRMS by root 2. This is your input here, this is your input current. So your IRMS is your 10 root 2. Your IRMS is 10 root 2. So this is 10 root 2 is equal to I by, this is I root 2. This is root 2. So here your IRMS, that will be equal to root 2 into root 2, that is 10. Here your IP, so primary, sorry, primary, it is your primary is 10 root 2. 1 minute, we need not know, this is not required because primary, this is your input current is how much? 10 root 2 by 5, that is equal to Is. This is so this will be equal to 2 root 2. This is your output current. We have to find out the output current. So I will be equal to I naught sine omega t, the 100 pi into t. So your I naught is how much? That is 2 root 2. This is output. This is output current. So secondary. So current in the secondary, this is your output current. So this will be sine 100 pi into t. This will be 100 pi into t because this is your secondary current. IP, your primary input is this is your input current, and this Is, this is the output current. Now my next question is you have to find the electric field. The electric field in the region is given by 40x I. Find the amount of work done taking a unit positive charge from because I, so your work done will be this will be 0 to 5 along x-axis. F into dot dr. Your work done will be this. So your this is equal to 0 to 5. F is your 40x along, this is along x direction, so it will be dx, it is along the x direction, I cap, it is clearly given you. So this will be equal to 40 x square by 2, 0 to 5. So this will be equal to 40 into 5 square by 2. So this is 20. So this will be 20 into 25. So this will be equal to 500 joules. This will equal 500 joules. Now this is all problem sums and questions. I am dealing with only the problem sums, not the theory part. So this is all the problems which I have solved here. This is physics for class 12 2025 CBSE paper. So this is all about it.